Hey, hi everyone. I'm here with your 721 lesson, How Can I Calculate It? Analyzing Strategies for Dividing Fractions. So as you saw in Chapter 6, fractions are useful and necessary in many real-life situations. You use them to bake and share a pie, to measure cuts when building with wood, to read music, and more. In this lesson, you will explore strategies for dividing fractions without drawing diagrams. As you work with your team on the problems in this lesson, remember to make sense of what each answer means. We're going to start with 735. 735 says making bows. Obtain the 721 resource page Making Bows from your teacher. Jill is making hair bows for her nieces. She wants to know how many bows could be cut from the ribbon she has. The ribbon she has that is 3/4 of a yard long. Each bow takes 1/6 of a yard of ribbon. She wonders how she can figure out how many bows she can make. She drew the line diagram below. A. Work with your team to make sense of Jill's diagram. How many bows can Jill make? Be prepared to explain how the diagram shows the answer that Jill found and what her answer means. So go ahead and pause your video and answer part A. Okay, if you're back with me, you have answered part A. So let's take a look. So there are 4.5 sixths. Okay. In 3/4 of a yard. So in 3/4 of a yard, there's 1, 2, 3, 4.5, because here's the half, 6. So in 3/4 of a yard. So that means she can make 4.5 bows. Okay. Part B says, what if each bow required 5/6 of a yard instead? Work with your team to use another copy of Jill's diagram on the 721 resource page to estimate number of bows that she can make. Be prepared to explain your thinking. So now on your resource page, you can use this diagram 735B to help you. So go ahead and answer part B. Okay, so for part B, your answers could have varied, but what we wanted you to see here is hopefully you saw that she could make a little less than 1. Okay. That one's a little tricky. I'm going to kind of help you out and show you another way that we can think about dividing. So 740 is where I want you to look at. We're going to use common denominators to help calculate each of the following quotients. You may want to confirm your answers with diagrams. So we're going to kind of get away from the diagrams here. We don't want to confirm our answers with those, but I'm going to show you how to do this. So we have 12/5 divided by 3/10. So we just wrote this in a different way. Now, what we want to do is we want to multiply by the reciprocal of our denominator. So our denominator is 3/10, so we want to multiply by the reciprocal, which would be 10/3. So we are multiplying by 10/3, which is the supergiant 1. Now we just multiply across. 12 times 10 is going to be 120. 5 times 3 is 15. 3 times 10 is 30 over 10 times 3, which is 30. So when we simplify 30 over 30, that's just 1. So we have 120 over 15 over 1, which simplifies to be 120 over 15. We can simplify that again. How many times does 15 go into 20? It goes in 8 times. So 8 is your final answer. We're going to do one more together. Part B, 3/4 divided by 7/12. So we have 3/4 divided by 7/12. We need to multiply by our reciprocal of our denominator. Our denominator is 7/12, so we need to multiply by 12/7, both the numerator and the denominator. This is our super giant one. So 3 times 12 is 36. 4 times 7 is 28. 12 times 7 is 84. And 7 times 12 is 84, and 12 times 7 is 84. So when we simplify, we get 36 over 28 over 1, which is the same as 36 over 28. Ask yourself how to change this back into a mixed number. How many times does 28 go into 36? 1. And 28 to 36, you would have 8 left over. 28. We could divide that by 4. So that would be 1 and 2/7 as your answer. I would like you to try part C. Part C is your last question for today. When you're done, please make sure you upload a picture to the assignment on Google Classroom. And if you have any questions, let me know.